In this video we will take a look at the input data required by GemPy to build a structural geologic model. GemPy is based on a universal co-kriging approach to interpolate boundaries in the subsurface, which is very similar to some commercial packages. Please take a look at the reference literature in the video description for a detailed description of the mathematical background. This interpolation approach requires two types of input data: surface points and orientations. We define surface points as points in space that mark the boundary between two structural elements. Most commonly, these structural elements will be stratigraphic rock units, but can be any homogeneous volumes you want to model. In GemPy, surface points define the bottom boundary of a structural element. Orientations are measurements of the inclination of a structural element at a certain location in space. They can be located anywhere in space, but need to be assigned to a structural element. We define orientations by location and azimuth, dip, and polarity. A different accepted notation in GemPy is gradients. Simply enter the components of the normal vector as gx, gy, gz at the given location. In visualization, the normal vector is the one that will be displayed. Let's look at an example. After importing the required dependencies, we start by creating a new GemPy model. In this step, you can define various properties. We will focus on the most basic ones here and discuss advanced options in future videos. First step, our model needs a name. In addition, we set the extent and the resolution of our model. The extent limits the 3D space covered by the model, while the resolution defines the number of voxels in each direction of a regular grid. There are several ways of adding your input data to a GemPy model. We can simply use the importer helper and directly load CSV files that are in the correct form by passing the correct file path. Here's an example file for surface point input data, including the coordinates as well as the name of the corresponding structural elements. The orientation file contains coordinates, azimuth, dip, polarity, or the components of the normal vector, and again the corresponding structural elements. In a future video, we will look into different visualization tools, but here is a simple cross-section displaying our input data along the horizontal x-axis. Alternatively, data can be added manually. As before, we need to specify the input data and assign a structural element. Both approaches can of course be combined. And again, a simple cross-section including the points that were manually added. We hope you found this tutorial helpful. If so, leave a like on this video or maybe even stop by GitHub and grant GemPy a star rating. We truly appreciate it. Are there any topics you would like us to cover? Make sure to leave a comment. By subscribing, you make sure to miss no informative GemPy videos in the future. See you in the next video.